All right, guys, we're going to do some more examples on electron configuration. Uh, if you've noticed, I've done all these videos in the same shirt. It's the same day. I've been recording these videos for a while. Want to apologize, this is not as high quality videos as I would have liked. I still haven't, gotten all my supplies and stuff, but actually, everything's shut down right now. So we can't even order anything anymore. So all the things I order are stuck at central receiving. And today we learned that, it's at least possible. People are spreading a lot of rumors and stuff. It's hard to know, but it's possible I won't even be able to come to my office anymore. So I'd have to record these from home. And I'm not equipped to to record at home. I don't even have a good enough computer or an internet connection that's good enough to do this. So I really have to churn through as many of these as quickly as possible. And so, if I'm making mistakes or something like that, or things are a little slow, I can't really record the video. I have to re-record the video. I have to go as fast as I can. So I just want to apologize for that. That being said, right, please email me. We can always communicate via the phone or via Zoom or via email or something to make sure that you can understand this content. But, we'll get through it. And the nice thing is, of course, as I said before, you can replay these videos, right? And so we'll get there one way or the other, okay? I feel bad for your labs. That's what's really suffering is the labs. Labs are great. Research is even better, okay, than labs, by the way. Labs are terrible compared to actual scientific research, but that's the way it is, okay? Do research if you really want to get into chemistry. You can talk to me about that. All right, so let's do some more examples. So let's do oxygen, okay? What is the electron configuration of oxygen? And so how we do this is we look on the periodic table. It has 8 protons. It's atomic number 8. And so there's 8 electrons. And so the electron configuration is going to be, we're going to fill up the 1s first, 2 electrons, the 2s second, 2 electrons. And then we're going to fill up 4 electrons. And we're going to follow Hund's rule. So we're going to put them in separate orbitals first. So here I put spin down, spin down, spin down. And then only by the time we get to the 4th are we going to start pairing electrons, right? And so we'd write this out as 1s2, 2s2, 2p4. 2 plus 2 plus 4 is 8 total electrons, okay? And so that's where they all are, right? There's the 1s, the 2 and the 1s. Those are the 2 electrons in the 2s. Those are 2 in the 2px orientation, 2py orientation, and the 2pz. Sort of gives you a picture of where these electrons actually are in the atom, okay? And so at this point, you should be able to use the shape of the periodic table to help you, okay? Come up with the electron configuration of any element. Now, if you're looking at your book or various resources online for this, there are some exceptions to this building up, this Aufbau principle. We will not go over those exceptions in class. You will not be responsible for any of those exceptions. Exceptions on the exam, there's just some weird intricacies of quantum mechanics that make it this way. For example, copper has an electron configuration in the ground state that you wouldn't expect. Chromium does too. Silver is another exception. Don't worry about the exceptions. I don't like you memorizing stuff in this course. You guys know this at this point. I try to get rid of as much memorization as possible. That's sort of my mantra. I want you to know the basic concepts. I don't want you to know intricacies that at this level you can only memorize because they don't make sense otherwise, okay? You're not equipped to understand those exceptions, and so let's not just worry. Don't worry about them, all right? Now, some of the homework problems might have some exceptions, and so you have to Google the answers for those, okay, or to look up those exceptions. But that's fine. I might have gotten rid of most of those. Hopefully I did. So anyway, this is how it's going to build up, okay? You're going to start at the NS. So you're going to start at the 1s, and you're going to wrap around to lithium, 2s, 2p6. So let's do it all the way. 1s2 to get to helium, 2s2 lithium, 2p6 brings you to neon, 3s2, that's going to get you here, that's magnesium, 3p6 gets you to argon. 4s2, that's going to get you to another alkaline earth, calcium. Then you go through the transition metals. There's 10 of them, 3d10. Okay? That's going to get you all the way to zinc. Zinc is at the end right here. Then you're going to go 4p6, krypton. Then you're going to go 5s2, rubidium. Then you're going to go 4d10. Okay? Now you might be wondering, why did I go from 4s2 to 3d? Again, intricacies of quantum mechanics of the relative energy spacings of those. But remember, there is no 2d orbital. Okay, that's why we didn't have a d block here. And there's no 3f orbital. That's why we didn't have an f block here. Okay, so let's go through it just starting from the beginning. 1s2 gets you to helium. 2s2 gets you to beryllium. 2p6 gets you to neon. 3s2 gets you to magnesium. 3p6 gets you to argon. 4s2 gets you to potassium. 3d10 gets you to zinc. Okay. 4p6 gets you to krypton. 5s2 gets you to rubidium. Okay. 4d10 gets you to cadmium. 5p6 gets you to xenon. 6s2 gets you to barium. 4f14 gets you to lutetium. Okay. And then you're going to be over here. That's going to be, so we did 4f15, 5d10. That's going to get you to mercury, Hg. 6, or row 6, right? 6p6 gets you to radon, Rn. 7s2, that gets you to radium, Ra. And then you have your last F block, 5f14. Why is there 14? 7 different orientations. -3, -2, -1, 0, 1, 2, 3. Those are the 7 F orbitals. Okay. Anyway, 5f14, 6d10. That's going to get you to element 1112. Okay, and nobody talks about these elements really. And then 7p6. Okay, and so that's basically it. That gets you to element 118. So if you can get to element 118, you can do all of them. Okay, so let me just write that out for you again, because I think that's really important so that you have that. So let me write that out on the screen share here. So let's share that screen. And so again, I'm just looking at the periodic table here, and I'm using the shape. Okay, I'm using the shape of the periodic table to help me get there. Okay, to help me get that far. And that's the basic idea here. So it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, okay, 4p6, okay. We're at 4p6, that got us to krypton. Now we're at 5s2, this is all one line, but I can't fit it all on here. And now we go to 4d10, 5p6, 6s2, 4f, we're into the block S, 4f14. Intricacies of quantum mechanics, guys, but use the periodic table to help you, use the shape of the periodic table to help you get this far, okay? 4f15, 5d10, 6p6. Now we're at 7s2. And then we're going to do, we're at the F block. I'm using the shape of the periodic table to help me. 5f14, 6d10, 7p6, and that's it. There's as of now, there's no known element 119. Okay, so that one I can just erase. But anyway, so that's basically it. All right, so let's stop this video there.